Hello, I'm Lou Bloomfield and welcome to How Things Work at the University of Virginia. Today's topic, ramps. People have been using ramps for heavy lifting since long before the Great Pyramids were built. Whenever something is too heavy to lift straight up, the simplest solution is often a ramp. As long as the slope of that ramp is gentle enough and you have something like wheels to keep friction at bay, you can lift almost anything from here to there. You use ramps without even thinking about it. Whenever you drive or bicycle up a hill, you're using a ramp to lift yourself to that hilltop. Consider the alternative, traveling straight up a cliff face to that hilltop. Not for everyone. Ramps are just as useful for lowering things as they are for lifting them. Suppose, for example, that you have a piano on a ledge and you want to lower it to the ground. Well, you can push the piano off the ledge and it will arrive at the ground, but don't expect it to be in tune when it gets there. You do a lot better to lower that piano much more delicately, more carefully, by taking it down a ramp. Ramps, also known as inclined planes, are one of the 6 simple machines. The other simple machines are levers, wheels, pulleys, wedges, and screws. In telling the story of ramps, however, I'll be laying the physics groundwork for all the simple machines, namely that they allow you to change the amount and/or the direction of the force you're using to do something. Doing something is of special significance in physics because it often involves the transfer of an important physical quantity, energy. The term energy is familiar, but people use that term to describe a broad range of concepts, only some of which are the physical quantity. One of my goals for this episode, then, is to explain what physicists mean when they talk about energy. For now, you can think of energy as the capacity to do things. In other words, the more energy something has, the more it can do. With that in mind, let's return to look at ramps, and I want to ask you a question to think about. That is, I'm not going to ask you to answer it yet, but you should keep it in mind as we continue to look at how things work. As background, ramps come in all shapes and sizes. There are ramps that are long, and there are ramps that are short. There are ramps that are low, and there are ramps that are high. And with that as background then, here's the question. When does this wagon have the most energy? That is, the most capacity to do things? When it's at the bottom of a long ramp, the top of a long ramp, the bottom of a high ramp, and now I want to end the ramp right around here, so it's not long, it's high. So the bottom of a high ramp or the top of a high ramp. To guide us through the study of ramps, we'll pursue 5 how and why questions. Why doesn't a wagon fall through a sidewalk? Why does the sidewalk perfectly support the wagon's weight? How does a wagon move as you let it roll freely on a ramp? Why is it more exhausting to lift a wagon up than to lower it down? Why is it easier to pull a wagon uphill on a ramp than to lift it up a ladder? There's a video sequence for each of these questions and a summary video at the end. And now, on to the first question.